Hello friends, welcome. Friends, many of my viewers have been requesting me that I create a video series to explain a technological concept end to end. So in order to keep that request, I have started with the first technological concept called satellite system. So here I'm going to have a series of video which is going to explain each and every dimension of this technology. So the first module of this series is titled Foundation of Satellite Systems. So this is an introductory module. It is going to cover and explain to you why communication satellites are needed and why we can't just live with terrestrial systems, which are the mobile communication system, which we all use. Then how this whole thing started from GEO, MEO to LEO. GEO is geosynchronous satellites, MEO is medium or Earth orbit satellites, and the LEO is low Earth orbit satellites. So what are the difference between these satellites and what are the challenges and what are the advantages and disadvantages? So these are the trade-offs between these three systems. And then we are going to basically talk about why orbital slot and spectrum are managed by a central authority in case of satellite system, whereas in case of terrestrial system, mostly it is managed within the country by the government, right, of that particular country. So what I've done is I've created some animations. Now, looking at this animation, the idea that you are going to get is going to be more entrenched and you will be able to appreciate the concept better. So the first thing we are going to understand is that why can't we use a base station, the terrestrial base station, to get the same job done which a satellite system is able to do? Because we have been already using terrestrial base station for our mobile service requirement. The friends, the problem with the terrestrial system is that the power that the terrestrial system is capable of transmitting is limited, though it is also limited, for satellites also. But the coverage of a terrestrial system is not limited by the base station, but it is limited by the mobiles transmitting back to the base station, because mobiles are systems which are very, very small and the battery life has to be managed so that you get a larger usage for the full day. And there is another limitation for mobile is that the mobiles can't transmit at a very high power because of EMF limitation, means it should not be harming your body. That is the reason why the coverage gets limited. Another reason the coverage gets limited is because the horizon of the earth, it blocks, because you know that the earth is round. Because the earth is round, you can't be transmitting at very large distance using one single base station. You have to use multiple of those base stations, and in some locations where the population is very thin, you can't put base stations, and because you will not be able to get any commercial benefit, because those base stations will be very difficult to manage and you will not get any subscriber, right? That is which is why we need to have satellite system. Now this satellite system are doing what? They are revolving around the surface of the earth. Now you see here there is a satellite system here which is going around the surface of the earth, right? So, if I make it geosynchronous and I just zoom out, you'll see that this satellite system, which you see here, it is a geosynchronous orbit. It is moving in a geosynchronous orbit, which means that the revolution of the Earth and the revolution of the satellite, right, in this orbit is synchronous. Means it will be appearing to be stationary from the surface of the Earth, right? Now, the problem with this kind of system is that it is at a great height. The height is 36,000 kilometers, right? It's very, very large. Now, as you reduce the height, let's say if I make it to MEO, you'll see that the satellite is now closer to the Earth, but the speed of the satellite has increased significantly. In case of GEO, the satellite was moving at a lower speed. You can see the speed here, 9,719 kilometers, and the height is 36,000 kilometers. In case of MEO, the speed has increased considerably, 15,596 kilometers, right? And in case of LEO, the speed has further increased to 23,224, right? 242 kilometers per hour. Why the speed increases as you move closer to the orbit or closer to the surface of the earth? Because the satellite needs to be prevented from crashing to the surface of the earth. Because if the speed was not high enough, then the satellite would crash to the surface of the earth, right? So that's a simple physics. Everybody will know that, right? Now let's go to the next animation. So this is the geostationary satellite, right? You see, which we spoke about. This satellite is going to have a coverage nearly, if you have 3 satellites and they are all spaced apart by 120 degrees, then you can have nearly 100% of the earth will get coverage. So that's the advantage of geostationary, but the orbit has to be 36,000 kilometers, right? So, but the problem is that with geostationary satellite is that if you have a geostationary satellite, then what happens is, this is the problem that you see. This satellite is here, and if you use a ground terminal here, and the ground terminal is transmitting to the satellite, and the satellite is transmitting back, there is a round trip distance of 71,000 kilometers, right? Roughly around 71,000 kilometers. Because the uplink and the downlink are 36,000 kilometers, so it is 77,572 kilometers. And this, if you divide by the velocity of light, there is a huge latency. And this latency can be as high as how much? You can see that it is roughly around 480 to 600 millisecond. Now, this latency makes it impossible for making any kind of voice communication because you have to wait, right? And even in data, the latency is not very good. And that is, which is why, friends, that we have moved away from geostationary satellites to MEO and LEO, because MEO and LEO is going to give you better latency. I'll tell you, as well as experience from a point of view of voice coverage as well as data coverage. So let's look at this. So we have got geostationary satellite here. See, these 3 satellites which we spoke about at a height of 36,000 kilometers. Now, as I reduce the orbit, you see that if the orbit is reduced, what happens is that in order to cover Earth, right, you need now more number of satellites. You can't just do with only how many? 3 satellites. Because the footprint of the satellites, here is the footprint of the satellite. This footprint of the satellite will be determined by the height. Because more the height of the satellite, larger will be the footprint, right? You see this very clearly. This satellite, if you have a higher satellite, the footprint is larger. But if you reduce the satellite, the footprint becomes much, much smaller. You see? Here, if you see, the footprint becomes much, much smaller. If you reduce this further, the footprint becomes much smaller. So first is that you need very large number of satellites in order to cover the full Earth, right? If you have to reduce the orbit, right, height of the satellite from the surface of the Earth. Unlike in case of GEO, which is 36,000 kilometers. The advantage that you get is that you have now a very low latency. Now, if I increase the orbit, you see that the latency was very, very high. You see, GEO, the latency is high. But when we reduce the orbit, you see the latency now becomes very low, which means that LEO satellites are capable of providing voice services which the GEO satellites cannot because of the latency. And LEO satellites, another advantage of LEO satellite is that because the large number of satellites are used, they can reuse frequency. Just like base stations on ground, they are reused, and you can have better capacity in limited quantum of spectrum. Because if you had used only GEO, then what happens is that spectrum is limited, and then the footprint is so large that the whole population is using the same pipe, same spectrum here. In case of LEO, what happens? There are large number of satellites are there, and therefore the footprint now is divided into small areas, and these areas the population can be divided and the people can use a smaller chunk of geography. They will be sitting on a smaller chunk of geography, and that spectrum can be divided into these geography, just like we do base stations. We deploy a large number of base stations to do frequency reuse. Now, the last question: why satellite spectrums are coordinated? Why it is coordinated? Now, if you look at in an uncoordinated system, if the systems were uncoordinated, like you see this animation, and these 2 satellites are close to each other, the beams of these 2 satellites are going to collide with each other. They are going to interfere with each other. So there has to be a central system which not only allocates this orbital slots, but also are able to segregate the system in such a way that the beams do not interfere with each other and they don't spill over to each other country, right? So that is the reason why the satellite systems are always coordinated, and the terrestrial systems cannot be satellite systems are always coordinated by central agencies like ITU, and the terrestrial systems can be coordinated within the country. So that's all, friends, in this video. You can I hope that you will like the video, and I will come out with the next module of this video going forward, and this is going to extend this discussion further. Thank you, my friends, for listening till the end. I'll come back with the next module soon.